In question 8, the problem statement is actually quite extensive and it's a very interesting question. So the statement says, in right triangle ABC, which is right angled at C, so ABC right angled at C, M is the midpoint of the hypotenuse AB. So M is the midpoint of AB. So let's represent it like this. So AM and BM are equal. Now C, this right angled vertex, is joined to M, and this CM segment is produced up to this point D such that DM is equal to CM. So DM is equal to CM. And now point D is joined to point B, this vertex of triangle ABC. Now we have to show that triangle AMC is congruent to triangle BMD. Then we have to show that angle DBC is a right angle. Then we have to show that triangle DBC is congruent to triangle ACB. And finally, we have to show that CM is equal to half of AB. So a bunch of things to be proved. So let's start with part 1. Triangle AMC congruent to triangle BMD. So this is what we have to show. So let me highlight these two triangles first. So triangle AMC is AMC, this triangle, and triangle BMD is BMD, this triangle that you see here. So we have to show that these two triangles are congruent, and this actually is quite easy. It's evident from the figure how we should do this. So in triangle AMC and triangle BMD, we have AM equal to BM. This is given to us. M is the midpoint of AB. Also, we have CM equal to DM. This is also given to us because CM was extended up to point D such that DM equal to CM. So we have this second pair of sides also equal. And also between these two equal side pairs, we can see that this angle AMC is equal to this angle BMD, because both of these are vertically opposite angles. So angle AMC is equal to angle BMD because these are vertically opposite angles, and hence we can now claim that triangle AMC is congruent to triangle BMD using the SAS congruence criterion, because we have two equal side pairs and the included angle pair as equal. So the first part we have proved that the two triangles AMC and BMD are congruent, and this means that all their corresponding parts will be equal. So for example, this angle here CAM will be equal to this angle here. These are the two corresponding parts. These are corresponding. So one mistake that I've seen students make here is they take this angle to be equal to this angle, but actually that's not true. This angle at A is actually equal to this angle that I've drawn here. So in other words, let me write it here. Angle CAM is equal to angle DBM using CPCT. And now you can see that these two angles CAM and DBM, they are alternate interior angles, and if they are equal, this means that these two lines must be parallel. CA and BD must be parallel. So from this we can conclude that CA is parallel to BD. And now because these two lines are parallel, now if this angle is 90 degree, the angle at C, angle ACB, it must mean that this angle DBC is also equal to 90 degree, because these two angles are co-interior angles. So we have proven the second part, that angle DBC is a right angle. And how did we do that? We use the fact that using CPCT, this angle, let me actually highlight it in color. So we use the fact that this angle here must be equal to this angle here, and these are alternate interior angles. So if these two are equal, then AC and BD are parallel, and if AC and BD are parallel, this means that the angle at B, at DBC, must be 90 degree as well, because angle ACB is 90 degree. Okay, now we have to prove that triangle DBC is congruent to triangle ACB. So let me highlight these two triangles now. So triangle DBC is DBC, this triangle, and triangle ACB is ACB, this triangle. So these two triangles are congruent is what we have to show. So let's do that now. So in triangle DBC and triangle ACB, let's compare the corresponding parts and see what we get. So we note that BC is equal to BC because this is common to both the triangles. So this is common, and we have angle DBC, this angle DBC, this is equal to angle ACB because both of these are equal to 90 degrees. So we are using the result of part 2 here when we showed that angle DBC is a right angle. Now we have two corresponding pairs of parts equal. What could be a third part? So well, we proved in part 1 that triangle AMC is congruent to triangle BMD, and this also means that AC, this side, is equal to BD, this side. Okay, so this is what we can use now. So we can say that DB is equal to AC using CPCT on the result, on the congruence result we got in part 1. So we now have two side pairs and the included angle pair equal, and this means that triangle DBC is congruent to triangle ACB using the SAS congruence criterion. Okay, so that proves part 3, triangle DBC congruent to triangle ACB using SAS. Finally, we have to prove that CM is equal to half AB. Now let's use the result from part 3. So because triangle DBC and triangle ACB are congruent, we note that their hypotenuse is let me highlight those. So the hypotenuse of triangle DBC is this side DC, and the hypotenuse of triangle ACB is this side AB. So these two will be equal. So we have DC is equal to AB using CPCT, and this means that if we take half of these, they will also be equal. So half of DC will be equal to half of AB. But what is half of DC? Well, because M is the midpoint of DC, then half of DC is either DM or CM. So let's take that as CM, and half of AB is AM or BM. But what we just need to show is CM is equal to half of AB, so we can leave it at this. So CM is equal to half of AB. So this proves part 4, and let me recap how we did part 4. So we used the result from part 3 that triangle DBC and triangle ACB are congruent, which means that their hypotenuses must be equal. So DC and AB must be equal, and hence their halves must also be equal. So CM becomes half of AB. So that proves all 4 parts of this problem. I hope that you enjoyed the problem. It's actually a very interesting problem. The solution is quite extensive. So make sure that even after watching this video, you try working out all the 4 parts on your own once again. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.